Hello my dear learners, welcome to NIUS Secondary Science and Technology classes. Today we will going to discuss about metals and non-metals. This is part 1. In this part we will going to discuss about the definition of metals and non-metals and the position of metals and non-metals in the periodic table. The topics which we will going to discuss today: periodic table of elements, discovery of elements. Then we will going to discuss about general characteristics of periodic table. Next we will going to discuss about general characteristics of metals, non-metals and metalloids. And lastly we will going to discuss about the position of metals, non-metals and metalloids in periodic table. After completing this session, you will be able to understand how classify metals, non-metals and metalloids. You can understand the position of metals, non-metals and metalloids in the periodic table, and you can differentiate between metals, non-metals and metalloids. So here is the periodic table on your screen. First of all, we have to understand what is the meaning of periodic table. The periodic table is a tabular array of the chemical elements organized by atomic number from the element with the lowest atomic number, that is hydrogen, to the element with the highest atomic number, that is oxygen. The atomic number of an element is the number of protons in the molecule of an atom of that element. So in our periodic table, these are known as groups. So in the periodic table, there are total 18 groups and 7 periods. These are known as periods. So there are total 7 periods in the periodic table. In first period, there are only 2 elements. In second and third period, there are total 8 elements. In fourth and fifth period, there are total 18 elements, and in sixth and seventh, there are total 32 elements. So in this manner, we can say that first period is very short period, second and third period is short period, fourth and fifth period is known as long period, and sixth and seventh period is known as very long period. So this is about periods and groups. If we talk about block elements, so in our periodic table, the elements are basically divided into different kinds of blocks like S block, P block, D block and F block elements. So group 1 and 2 is known as S block element. From boron to helium family, these are known as P block elements. In the middle of this S and P block element, these are known as D block element or transition element. So basically in our periodic table, elements are divided into metals, non-metals and metalloids. If we talk about metals, so in S block elements, metals are present. The position of non-metals are basically in P block. So most of the elements in P block are non-metals, and metalloids, some metalloids are also there. Metalloids are also there, which we will going to discuss later. What are metalloids? So basically, first group elements are known as alkali metals. Alkali metals. This second group elements are known as alkaline earth metals. Alkaline earth metals. And these D block elements are known as transition elements. And this green color elements are basically basic metals. These are basic metals, and these blue color elements are known as non-metals. non-metals. If we talk about this violet color elements, these are known as halogens and they are basically non-metals. Then if we talk about these purple group elements, these are basically noble gases. Noble gases. Why they are called so? Because noble means not to able to react. Here we will going to discuss about the reactivity manner. So noble gases are basically unreactable in nature. If we talk about these elements, they are basically from lanthanum family. That is why they are known as lanthanoids. Lanthanoids. And in the below side of lanthanum family, these groups are known as actinoids because they are basically from actinium family. So they are actinoids. So this is about our periodic table. So next we will going to discuss about elements. Science has come a long way since Aristotle's theory of air, water, fire and earth. Scientists have identified 92 natural elements and created about 28 others. Chemical elements may also be categorized by their origin on Earth, with the first 94 considered naturally occurring, while those with atomic numbers beyond 94 have only been produced artificially as the synthetic products of man-made nuclear reactions. Of the 94 naturally occurring elements, 83 are considered primordial and either stable or weakly radioactive. The remaining 11 naturally occurring elements possess half-lives too short for them to have been present at the beginning of the solar system and are therefore considered transient elements. Of these 11 transient elements, 5 that are polonium, radon, radium, actinium and proactinium are relatively common decay products of thorium and uranium. The remaining 6 transient elements that are tectinium, promethium, astatine, francium, neptunium and protenium occurs only rarely, are products of rare decay modes or nuclear reactions possess involving uranium or other heavy elements. So as you can see on your screen, there is a picture of universe. So we can say that the elements alone or in combinations make up our bodies, our world, our sun and in fact the entire universe. So next we are going to discuss about the most abundant element in the Earth's crust is oxygen. So if we talk about the most abundant element in our Earth crust, that is oxygen, and the percentage is 44.1%. The next most abundant element is magnesium and the ratio is 23%. And the third most abundant element is silicon, that is 22%. Rest are other metals like sodium 0.3%, aluminium 2.2%, calcium that is also 2.2%, iron that is 5.8% and other are in the ratio of 0.1%. So next we are going to discuss about Mendeleev's periodic table. So next we are going to discuss about Dmitry Mendeleev periodic table. On 17th February 1869, Russian chemist Dmitry Mendeleev jotted down the symbols of the chemical elements, putting them in order according to their atomic weights and inventing the periodic table. So what is the periodic table? Periodic table shows all known elements in the universe. So all elements shows in our universe or found in our universe are basically set a position in our periodic table. They organize the elements by chemical properties. So according to their chemical properties, they organized these elements into group and periods. A great deal of information about an element can be gathered from its position on the periodic table. So with the position of periodic table, we can easily identify what kind of element is this, what is the chemical or physical properties for this particular element. For understanding the organization and plan of the periodic table will help you obtain basic information about each of the total 118 elements known. So now our periodic table is completed. So there are total 118 elements. So how we can identify the properties? We can identify the properties of these elements with the help of their electronic configuration. So now the question arises, how do you read the periodic table? We can read the periodic table with the help of symbol of elements. For example, the symbol for carbon is capital C, a 1 or 2 letter abbreviation taken from the element's name. Next, we can identify with the help of atomic number. Now question arises, what is atomic number? The total number of protons in the nucleus of an atom is known as atomic number. The next thing is the name of an element. Next is mass number. So with the help of mass number, we can identify total number of neutrons present in an element. So what is mass number? The total numbers of protons and neutrons in the nucleus. So basically the position of protons and neutrons are in the middle or in the center of an element, and atomic mass is the equivalent to the number of protons and neutrons in the atoms. So this is basically atomic mass and this is the name of an element. So this is how we can read the periodic table. Now the question arises, what is atomic number? So as you can see on your screen, atomic number is basically written above to the element. For example, the atomic number for carbon is 6 and the atomic number for tin is 50, and the mass number of an element is written downside of the element. For example, for carbon it is 12.011 and for tin is 118.71. Now the question arises, what is the symbol? An abbreviation of the element's name is known as symbol. For example, if we talk about carbon, it is capital C. So next is, what is atomic mass? So the atomic mass is the number of protons and neutrons in the nucleus of an atom. Our next question is, how do I find the number of protons, electrons and neutrons in an element using the periodic table? So as you can see on your screen, number of protons are abbreviated as capital P, which are basically equal to the atomic number, which are abbreviated as capital Z. If we talk about number of electron, which are abbreviated as small e, it is equal to the atomic number that are abbreviated as capital Z. If we talk about number of neutrons, which is small n, they are basically equal to the atomic mass number that are basically rounded off, and its abbreviation is capital A, minus atomic number that are capital Z. So in this manner we can say that atomic number capital Z is equal to the total number of proton present in an element, which is also equal to the total number of electrons present in an element. If we talk about atomic weight or atomic mass, it is equal to the total number of proton plus neutron or total number of electron plus neutron. So this is about how we can identify total number of electron, proton and neutron in an element. Lastly, we will going to discuss about the position of metals, non-metals and metalloids in our periodic table. So, in this periodic table you can see this green color showing the position of non-metals, and this is the place for hydrogen. So, we can say that hydrogen is a non-metal. This blue color showing the position of metals. So, most of the elements present in our periodic table are basically metals. So, all the S block element, D block elements and some of P block elements are basically metals. This purple color shows the position of metalloids. So, you can see on your screen these are basically non-metals and they are showing the properties of metals as well as non-metals. So, this is about today's class. In this class, we have been discussed about metals, non-metals and metalloids. We have been discussed about periodic table, and lastly, we have been discussed about the position of metals, non-metals and metalloids in our periodic table. In my next part, we will going to discuss about the properties of metals, non-metals and metalloids. Thank you.